Hi students, welcome to this video. Now in this video, we are going to study for Neet and JEE exam. So the branch of physics we are going to discuss in this video is heat and thermodynamics. So first of all, let us see some topics related to heat and thermodynamics. So we first going to study the meaning of temperature, then the temperature conversion scales. Normally, heat and temperature both are related parameters. Thermodynamics totally explain the phenomena related with heat and temperature only. It is a very important branch of physics. Okay, so now let us see the definition for temperature. You observe this video, like and share this video, and also subscribe my channel. Now let us go into the topic one by one. First of all, what is temperature? The temperature is the degree of hotness or coolness of a body. Hotter the body, higher is the temperature. So the temperature will determine the direction of heat flow when two bodies are in thermal contact. Normally the temperature will flow from higher temperature body to lower temperature body. The SI unit of temperature is Kelvin. Okay. So in our day-to-day applications, also Celsius, Fahrenheit scales are also used. Heat is a scalar quantity. The units of heat is joule, erg, calorie, kilocalorie. Okay, so there are different units. Now, let us see the temperature conversion. So, to convert between Fahrenheit and Celsius. Okay, so let us see the formulas one by one. C is equal to 5 by 9 into F minus 32. So, this is a formula to convert from Fahrenheit to Celsius. The next one, you simply rearrange the formula, we will get F is equal to 9 by 5 degrees Celsius plus 32. Okay. Then to convert between Celsius and Kelvin, another formula is given. So C is equal to K minus 273 or K is equal to degree Celsius plus 273. So these Kelvin temperatures can never be negative. Okay, wow. So these are the two important formulas. Okay, right. So these formulas are used to convert from Fahrenheit, Celsius and Kelvin. Okay. So next let us see an example. So how to convert Fahrenheit to Kelvin? So the formula is K is equal to degree F plus 459.67 into 5 by 9. So let us consider as an example, convert 75 degree Fahrenheit to Kelvin. So substitute the value, we will get the answer. Okay, va? So the next thing we are going to discuss Boyle's law. Right? So this Boyle's law is very important. For a given gas at low pressure kept in a container of volume V, the experiment revealed the following information. So the informations are converted as laws. Okay. So let us see the Boyle's law statement. When the gas is kept at constant temperature, the pressure of the gas is inversely proportional to the volume. Okay. So P directly proportional to 1 by V. So this law was discovered by Robert Boyle. Therefore it is called as Boyle's law. So in the picture, two beakers are there. So in the first beaker, a gas is expanding. Therefore volume increases, pressure decreases. So the second one, right? So pushing down. So when the piston is pushed down means pressure increases, volume decreases. So this diagram illustrates Boyle's law. Okay. Now let us see Charles' law. Right. So the Charles' law statement we will see. At constant pressure, each degree rise in temperature of a definite mass of a gas, the volume of the gas expands 1 by 273.5 of its volume at 0 degrees Celsius. So the formula is Vt is equal to V0 into 273 plus T degrees Celsius divided by 273. Okay, therefore Vt is equal to V0 into capital T divided by 273. Okay, va? So let us see the exact statement for Charles' law. When the gas is kept at constant pressure, the volume of a gas is directly proportional to the absolute temperature, V directly proportional to T. It was discovered by Jacques Charles. Therefore, this law is known as Charles' law. So a diagram is given. Initially, see the first diagram. So the first diagram, the temperature is low. So therefore, the volume of the balloon is smaller. See the second diagram, the temperature is increased, therefore the volume also increases. Okay, therefore volume is directly proportional to temperature when the pressure is kept constant. Okay, so another thing you should know, that is combining Boyle's law and Charles law, we get an equation, that is PV is equal to mu RT. That equation is called the equation of state. Okay, right? So the Boyle's law and Charles law, these two laws are very important in thermodynamics. Now we are going to see the definition for heat capacities, right? Generally we are having heat capacity, specific heat capacity, then molar specific heat capacity and latent heat capacity. Okay, first of all let us see one by one. So what is heat capacity? It is defined as the amount of heat energy required to raise the temperature of a given body from T to T plus delta T. Therefore, to raise the temperature of a given body to a particular temperature. So, the formula is CH is equal to Q divided by delta T. The unit is joule per degree Celsius. The next one, specific heat capacity. Specific heat capacity of a substance is defined as the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 degree Kelvin or 1 degree Celsius. Okay, this is known as specific heat capacity of a substance. The formula is noted as Cs is equal to Q divided by M into delta T. So the unit is joule per kilogram per degree Celsius. The dimensional formula is L square T square theta power minus 1. Next, we will see the definition for molar specific heat capacity. Right? So, the molar specific heat capacity is defined as the heat energy required to increase the temperature of 1 mole of a substance by 1 degree Kelvin or 1 degree Celsius. So, the formula is C mu is equal to Q divided by N into delta T. Here N represents the number of moles. Okay. So, the unit for molar specific heat capacity is joule per mole degree Celsius. Okay. So, the dimensional formula for molar specific heat capacity is mL square T minus 2 theta minus 1. Next, we will see another simple formula for specific heat capacity. That is C is equal to del E divided by M into del theta. Here, del E represents the change in thermal energy. So, this is also another important formula for specific heat capacity. Okay. Now, let us see some values for specific heat capacities of different materials. Okay. So, let us see one by one. For air, right, the value is 1.005. For lead, the specific heat capacity is 0.13. Similarly, for copper, the specific heat capacity is 0.39. So, like this, if we continue the tabular column, the specific heat capacity for water is given as 4.186. Okay, so among all the materials, the water has the highest value of specific heat capacity. For this reason only, water is used as a coolant in power station and reactor. Okay, remember, water is said to have the highest value of specific heat capacity. The specific heat capacity for water is 4.186. Okay, next, this molar heat capacity at constant pressure. Okay, right? The molar specific heat capacity at constant pressure means Cp. So, this is the definition for Cp. And another definition also we are having, that is molar heat capacity at constant volume also. Okay. So, you go through the same formulas are also given here. So, the next thing we are going to see the specific heat, latent heat. So, first of all, let us study what is latent heat capacity. If you consider a boiling pot of water, the temperature of the water increases up to 100 degrees Celsius. That is the boiling point of water. Then the temperature remains constant until all the water changes from liquid to gas. Okay, so during this process, the heat is continuously added to the water. But the temperature of water does not increase above the boiling point. This is the concept of latent heat capacity. Okay, so if we supply continuously heat only up to boiling point, right, the water temperature will rise. After that, the temperature of the water will not rise. Okay. Now, what is latent heat capacity? So, let us see the definition. Latent heat capacity of a substance is defined as the amount of heat energy required to change the state of a unit mass of the material. Okay. So, the formula is Q is equal to M into L. Okay, here L represents the latent heat capacity of the substance, right? Q the amount of heat, M the mass of the substance. So the SI unit for latent heat capacity is joule per kilogram. Now let us see an example. Here an example is also given. The specific latent heat of fusion of ice is 330 joule per kilogram. How much energy is needed to melt 0.65 kilogram of ice? So del Q is equal to ml. Okay, so m is 0.65 kilogram. You multiply this by 330, so the answer you will get is 210 joules. Okay, this amount of energy is needed, right? Then next one. So we will consider now the change of states, because heat means immediately we can think of change of states. Okay, there are different steps in change of state. Okay, first of all, if a solid is converted into liquid, then the process is called melting. Okay, here in the diagram 6 processes are given, so let us see one by one, right? So melting means solid to liquid, then evaporation means liquid to gas, then sublimation means solid to gas, then freezing means solidification, or it is the conversion of liquid to solid state. Then next one, condensation. Condensation means the conversion from gaseous to liquid state. So these are the changes of states of matter. Okay, right? Now we discussed in this video the major important topics in thermodynamics. Okay, so you observe this video, like and share this video, and also subscribe my channel. Thanks for watching.